All right, class. In this video, we're going to go over the chi-square analysis using the M&M lab. Chi-square is a good mathematical way to show when there might be any inconsistencies in a data. If there's something happening in an experiment that's causing something to change, consider you roll a dice and we're getting a lot of ones. There might be something wrong with the dice, and that would show, based on the chi-square analysis, if it's an accurate piece of equipment or not. Okay, in this test, we are going to look at M&M candies and determine if there's a random assortment of colors that come out with the M&Ms, or is there something else going on where there's a different percent than what should be located. Okay, some background. The chi-square analysis is used to perform a hypothesis testing on nominal and ordinal data. Now, nominal data is qualitative for predetermined categories. For example, the gender in the categories are male or female. Ordinal data has all the properties of nominal with the added ability to rank the values from highest to lowest, like a restaurant having 5 stars, 4 stars, and so on. One way to conduct chi-square analysis with M&Ms is a goodness of fit test. This looks at a frequently distribution. Will it fit the predicted distribution? You may not know this, but when M&M candies are made by the M&M factory, these are the percentage of colors that should be made in a normal factory. So there are more blue M&Ms than other color M&Ms. Red, brown are the least amount. If you take 500 M&Ms, the probability of them being green would be the 500 times the 0.16%. So you move the percent as a decimal. So 500 times 0.16 would be 80 green candies. Then you can do the same thing for every other color candy. And then when you add them all up, that should equal to 500 candies. If you compare the observed values, that's what's actually in your M&M bag, to the expected values, that is in this chart, you'll see a chi-square that can be determined. This will be compared against a data table to determine the probability of obtaining a particular value. So then you're going to use a chart to determine, was the data statistically significant or not. The equation for chi-squared is the sum of every observed minus expected value squared divided by the expected value. So what you're going to do in your lab today, real quick, this shows the degrees of freedom. To find out the degrees of freedom is you look at the number of samples and you subtract it by 1. So if you look at the number of candies in the M&M bag, there are 6 pieces of candy. Subtracted by 1, and you would have degrees of freedom of 5. Now, the null hypothesis for this particular lab, you could state, if I open up a bag of M&Ms, there should be there should be a direct correlation between the number of candies and color based on the percentages that should be located. You want to see if you could accept or reject that null hypothesis. So again, if your data points, if your M&Ms are very close to these percents, that means that it is a normal M&M bag. If these are not the normal percents, you have to fail to accept the null hypothesis. Okay? Look at degrees of freedom of 5. If you happen to get a final answer bigger than 11.07, that means that there is something else going on. Maybe the factory was messed up and they're producing different colors, or some machine messed up. For the lab, you'll need M&Ms, calculator, put a paper towel below the M&Ms, paper or pencil. So you're going to separate your M&Ms into different colors, count and record the number of M&Ms in each category. Then once the entire class has counted it, let's get the class data. Determine the total number of M&Ms. Calculate the expected numbers. You're going to multiply the total number from step 6 by the percent as a decimal from the chart. You're also going to record both the expected and observed counts, and then determine the probability. I'll give you a worksheet where you fill out all your data points. In the end of the lab, you want to determine the probability, number 9, for the difference of the observed and expected values. Did it occur by chance, or was there a sign of something else? I also like you to state a null hypothesis for this experiment. If you have any questions, feel free to let me know. Have a good day.